Assalamualaikum and a very good afternoon to Dr. Zul and Dr. Ibrahim. My name is Nashita from Group 11 Section 1, together with my group mate Chong and Chuen. Today we're going to present this week's lab on data acquisition with AVR microcontroller. So this is the first experiment, which is an extension of last week's experiment on displaying 0 to 9 digits on LCD. So this experiment basically is a one-digit calculator. So we're going to simulate to see if it works. All right, so the first thing that the LCD will display is the welcoming introduction, that is first digit calculator, coming from our group 11. Next, it will display, it is supposed to display a 0 plus a 000, which indicates that it is ready to display numbers that are inputted by user through this keypad. All right, so now we're going to insert, for example, number 3A, which indicates a plus sign here, and 6. And replace C for equal, and we get number 9. Another example, 9. Oh, first we're going to reset, clear this first. 9 plus 9. Now we're going to put equal, C is equal. C is equal, A is plus, and this asterisk sign stands for clear. Another number, let's say 7 plus 9, 16. So as we can see, the one-digit calculator works perfectly. And we set a 1 second delay between showing each information, about 2 seconds delay between showing each information. So I believe that is all for the first experiment. Further discussion, for example, on why when displayed, the 0 sign has this extra blurred signs, which is actually not supposed to be there. It's just supposed to display 0, 0, and 0 here. This is an extra, so we're going to research that and put it onto our discussion. I'm going to pass it to my teammate to explain on the second experiment, which is to create a solution for a problem implemented onto an AVR microcontroller. Thank you.
Good afternoon, Doctor. I'm from Group 11 and my name is Chong Chuen. So in this task, in week 3, we'll implement for a car mode distant display system. So the right one will show the code and the left one is the simulation circuit. So when we try to compile, it show don't have any problem. So at the beginning of the system, so it will display mode, and then we don't need for the ultrasonic sensor yet when we using other mode than reverse. Then the LED and buzzer will remain stationary. So when the park mode is pressed, it will display mode is park. When the mode neutral is pressed, it will display neutral. So when the mode is drive, it will display drive. So I will demonstrate how is reverse mode. So when it's reverse mode, when reverse mode is pressed, it will display reverse mode, and then okay, let's see. The voltage source in here will be simulated for the distance detected for the sensor. So when the distance is less than, when the distance is more than 300 cm, which is 3 meter, it will state level far distance is, it will show the distance, the measured distance. So the LED and the buzzer will stay stationary. So what if the sensor detect is distance is more than 100 and less than 300 cm? So let's say 252 cm is in more than 100 and less than 300 distance. So the LCD will display the distance and show normal. And then the output, the LED will blinking, but the buzzer stays stationary. So when the distance is less than 100, it will display the distance, which 34 cm less than 100 cm. The level is will show very close. So we will know the distance is close, and then the LED will blinking and the buzzer will be beeping. So this is simulating for this software will be simulating for the distance, and then we will show the result on the LCD screen. So when the mode is we uh, when we don't press the reverse mode, and then it will come back to beginning. So that's all for this task. Thank you.